generally in the end of the experiment we want to identify metabolites that are significantly different, that are present at significantly different levels across experimental conditions. Then for this reason we have a function in Metab called age test, which is able to perform two types of analysis, or a t-test or ANOVA. Very simple. So the way it works is pretty similar to the way all the other functions I described before work. So if you see here, we have the requirements for this function is the input data. We have one of, let me show you it a bit bigger. Maybe it will be too small to see the details. So here are the requirements for this function. So you can see that require the input data, the signif level, which is the p-value that you set as threshold. So every metabolite that receives a p-value higher than the value you define here, it will be removed from the results. The idea is to report only those metabolites that are found at significantly different levels across experimental conditions. So if you want to show, to report all the metabolites, you can always change that parameter to 1. So basically you're going to show every metabolite. That's that. There is another option here called log transform. The idea is if you want to log transform the data before doing the t-test or ANOVA, so if it's true, it's going to do the ANOVA and t-test on the log transformed data, which is generally recommended to increase the normality of the data. You have another option here that's save equal true, the same idea. So if you want to save the results to be true, then folder. And there is one argument here that it's new, it's called stat test. So in this one you define which kind of statistical test you want to do. So if it's missing, if you apply the function without this argument, let's suppose that we apply this function like this. We are not going to save the results initially. So let's remove this folder. I'll leave it here. We're not going to use, but leave it there. So let's suppose we have a data set like this. Okay, we want to apply a t-test or ANOVA. So if you apply the function like this, it will use the default setting. So the signif level will be 0.05, and the data will be log transformed before the test, and the statistical test applied will be automatically chosen. So in this case we have only two conditions. Because we have only two experimental conditions, the best test for this situation is a t-test. So if I apply this function like this, it says here t-test in progress. So it performed a t-test. Okay, it's in here. Now if I want to perform an ANOVA, although I have only two experimental conditions, I can put here stat t-test equal A. Now it changed to ANOVA is in progress. So if you can actually write A, ANOVA, you can write ANOVA O capital, and if you want to apply a t-test, then you can put T, capital T, or lower t. You can actually write t-test, so it accepts different values for this variable. But the idea is that if you don't define a test, it will automatically decide if it's a t-test or ANOVA. If it's only two conditions, it performs t-test. If you have more than two conditions, it will perform an ANOVA. And if you want to save the results, the same idea. So let's put an output, saying that the output will be, let's say that we are not going to put an output for now. I want to save. Let's see what's the default value that it's going to define. So the folder used will be the same folder that we used in the function to normalize the biomass. So I want to save the results exactly in the same folder. So it's in here, and then I apply. So it's saying that it saved the function, it saved the file t-test in this folder here. So because it automatically decided to do a t-test, and you didn't define a name for the file that it generates, it gives the name of the file the same name of the test that was performed. So if I actually want a specific name for that, if I put output equal test, let's put statistical test. Okay, I want a file. I want it to generate a file called statistical test. And if I apply that, then here I have the file statistical test, where I have the abundance of all the metabolites, the same way as the input data, but in the end, in the last column, I have the p-value. The p-value is associated with each one of these metabolites. And you can see that most of them, in this case, are significantly different. You can see that this one has a value of 0. That's because we don't have enough samples to actually run the test, to actually apply the test. The same thing will happen if you have a metabolite presenting only one condition. The p-value here will be 0. It's not because the p-value is 0, but it's just because we are not able to apply the statistical test if it's presenting only one condition. And so that's the end of the functions from Metab. So using these functions, you can process the data from AMDIS in a very high throughput manner. You can decide if you want to recalculate the abundance, or using the area calculated by AMDIS, or using the base peak calculated by AMDIS. If you want to apply to a single file, you can apply on any of these functions here. Again, to recalculate the abundance, or to get the area, or to get the base peak. You can remove compounds considered false positives. You can normalize by internal standard. You can normalize by biomass. And finally, you can calculate the p-values associated with metabolites in the input data. So I hope it's clear enough to be able to use Metab in an easy way. If you have any question or any feedback, please feel free to contact me. And now I'm in the process of submitting this package to Bioconductor, so this package will be even easier to download pretty soon. And that's it. I hope it's useful for you. So thank you very much.